Regarding the time of the start of the lesson.
Speak louder, please.
Regarding the time of the start of the lesson,
Yes.
I mean, it's less optimal to start it earlier because then it means we have. I mean, there is a course just finishing before. So unless it's.
I don't get it.
Non, vous avez demandé si c'est possible à commencer le cours plus tard.
Oui.
Et moi, je trouve que c'est bien. Parce qu'il y a un autre cours qui est fini normalement. Par exemple, moi, j'ai un autre cours qui finit normalement à 4 ou moins quart.
D'accord.
Mais des fois,
Ça s'étend un petit peu, ouais.
Et du coup, si on commence le cours plus tôt, ça veut dire qu'il n'y a pas...
Il n'y a pas une pause très longue, ouais.
Oui, même, c'est quand même...
D'accord, mais 4h10, ça tirait ou
Oui, en tout cas, oui, ça peut se passer.
Parce que moi, ça m'aiderait, parce que ça m'aiderait à choper mon train à 7h54, en fait.
Ah oui. Ok, non, c'est le cas, alors, okay.
Sinon, ça me fait rester 1 heure de plus à Paris, quoi. Donc, je sais pas, j'espère que je vais l'avoir ce soir, mais je préférerais être plus à l'aise avec 5 minutes. 5 minutes de marche, ça m'aiderait, quoi.
Ah ok, non, mais c'est quand même bien sûr que vous... Oui, ok.
Enfin, voilà, c'est juste ça, hein. Voilà, c'est pas du tout... Mais 5 minutes, ça m'aiderait déjà beaucoup. Donc, si on peut commencer 5 minutes plus tôt, ça serait bien.
C'est une autre question. Les cours, il va continuer, en fait, il y aura cours jusqu'à quand? Est-ce qu'il y aura...
Oui, il y a 8 séances.
Et ils seront consécutifs
Oui. Donc ça va continuer jusqu'à mi-février, je pense, un truc comme ça.
Mi-février, on aura une petite pause après l'examen?
Voilà, je pense, oui. On va faire des séances d'exercice après.
Ah, il y aura des séances d'exercice?
Oui. Mais alors, je ne sais pas encore si je vais faire... je vais peut-être faire des séances d'exercice plus tôt, quoi. Je ne sais pas encore. Je vais voir, ça dépend à quelle vitesse on avance.
Plus tôt. Ce que je demande, en fait, est-ce que dans la semaine, par exemple, avant les semaines officielles des examens, est-ce qu'on aura une séance d'exercice ou de cours?
C'est quand la séance des examens? C'est
la deux premières semaines de mars. Donc, coup,
ah non, ça sera fini là. Non, ça sera fini.
Donc du coup, les périodes de cours elles continuent jusqu'à fin février, mais il y a comme un type de...
Voilà, il y en aura, ce sera des TD quoi. Enfin, il y en aura où ça sera des exercices, on fera des exercices ensemble.
Ah, on aura
une séance, ouais. Ouais, tout à fait, mais ce sera peut-être pas 3 heures, ce sera peut-être 2 heures ou un truc comme ça. Je sais pas, après c'est libre en fait. Moi je suis payé pour faire 8 séances de 3 heures. Et donc après, c'est gratuit quoi. Donc on s'arrange quoi. Enfin, c'est comme vous voulez après.
Mais normalement, vous pensez qu'il y aura de séances d'exercice?
Ah bah moi je le souhaite parce que sinon vous allez au casse-pipe quoi. Enfin à l'examen c'est un peu casse-gueule quoi. Donc je préfère que...
Moi, je veux savoir,
Alors soit ça sera une séance d'exercice, soit ça sera une présentation de vos rapports par exemple. Donc ça peut être sympa aussi de faire ça. Mais vu qu'on est hyper nombreux, je pense que c'est pas une bonne idée. Enfin je vois pas. Je sais pas combien il y en a qui suivront le cours jusqu'au bout. Mais là, vu comment c'est parti, ça fait beaucoup de gens, quoi.
En principe, il y aura des séances jusqu'à l'examen et après...
Ah non, pas jusque-là. Non, je pense qu'il y aura 1 ou 2 séances d'exercice et c'est tout, quoi.
Oui, mais je veux dire, il y a d'ici à mi-février, il y a 8 cours et après vous dites qu'il y aura une séance...
Voilà, 1 ou 2 séances d'exercice, ouais.
Et après, il y aura l'examen.
Voilà, c'est ça.
Donc on n'aura pas une semaine sans séance.
Je pense pas, non. Enfin, on va voir, ça dépend de ce que vous voulez faire, quoi. Si vous voulez, moi je suis libre pour en faire, sinon, voilà, c'est libre. Voilà, on décide ça ensemble, quoi. Voilà. Bon, on reprend. Comme ça, on terminera plus tôt. Allez. Ok, bon alors. So let's see. So we will consider the following problem. So you have an hard drive, okay, and you want to decide when to cut the power, when to shut it down, okay. So what's the cost of shutting it down? It's nothing, okay. It doesn't cost you anything to shut it down. The only thing is that the next time you will have a request, you will need to start it, okay, and this will cost you something, okay. To restart the hard drive, it will cost you something, okay. So what's going on is that you get from the operating systems some request of read of write, okay, and in order to satisfy this request, you need to have the hard drive on, okay. But letting it on, okay, so when the hard drive when the hard drive is on, it costs you X euros per unit of time, per second. Okay? If the hard drive is off, it costs you Y euros to restart it. Okay? And when the hard drive is on, you can serve any request. Okay? So basically, what's the cost of running the hard drive? What's the cost? So the cost of running the hard drive, basically, if you look at all the requests that will arrive, they will arrive at sometimes T1, then T2, Tn, okay? The cost of running the hard drive is simply the cost over all the interval. It's the cost of running the hard drive during each interval Ti plus 1, Ti minus 1 Ti. Okay? So the total cost of running the hard drive is simply the cost, the running cost of any of these intervals. Over any of these intervals. Okay? You just sum the cost over any of these intervals. Okay? So what do I mean by that? It was basically, so for the one that missed the beginning, so you run an hard drive. Okay? You have requests coming from the operating systems. Letting the hard drive on costs you 5 euros, X euros per second. Okay? And if the hard drive is off, when a request arrives, you need to shut it, to restart it, and this costs you Y euros. Okay, so the question is how to minimize the cost. Okay, so you have a sequence of requests that arrive. So the request I arrives at time Ti, and you want to serve them. Okay, serving them induces no cost. Okay, you just need to have the hard drive on at that time. So the question is, when do you shut it off? When do you restart it?
Can you wait with the request? Can you wait with the request?
No, there is no wait. Yeah, the request, we just need to serve them at some point. But the thing is that when the request arrives, we need to have the hard drive on. Okay, so when a request arrives, we just restart the hard drive, and we consider it's instantaneous, but cost you some money.
You cannot aggregate. You can't like aggregate, get some requests and then serve them all.
No. We need to have the hard drive on when a request arrives. Okay, or at least to restart it. Yes.
You cannot know in advance when the request.
No, it's online. Okay, so it's online. It's online. So we act immediately as a request arrives without knowing anything about the future. Yes?
You should know after having waited the time you had, the time for which you paid the cost of restarting.
Yes.
You are sure to much.
Exactly. That's the deterministic strategy that we will come up with. Okay. So, but let's first study what are the options. What are the options? Okay. So basically, the thing that I want to say is that simply the cost of running the hard drive is simply the cost of running the hard drive for each interval between two requests. Okay. But what I can say is that once I have served this request here, the hard drive is on here. The hard drive is on at the time I serve the last request. Okay? So basically the state of the system after each request is always the same. Okay? So basically what I have to study, so basically the cost is simply equal to the sum over all requests of the cost of serving this request I, given that the hard drive is on at time ti minus 1. Okay? So you can always suppose that the hard drive is on at time I minus 1, and now you have to minimize that. Okay? So we can just, so we are left with the study of the cost of serving one request given that the hard drive is on at time 0. Okay? Since the state of the system is always the same once we have served one request, okay, we can just assume that we just need to be able to minimize this cost. Serving one request, given that the hard drive is on. Do you agree with that, or do I need to try to explain it? Well, okay, so we are simply, so now the problem is now the following. The problem is now the following. The hard drive is on at time 0. Okay? Letting it run cost you X euros per unit of time. Okay? Shutting it down before serving, before the request arrive, cost you Y euros to restart it. Okay? So basically, what are the options? Is it good to shut it down, then restart it, then shut it down, then restart it, then shutting it down? Is it a good strategy? No. Once it's shut down, we wait until the next request. Okay? So basically, the only options for the algorithm is to decide when, how long it will wait before shutting it down if the request has not arrived yet. Okay? That's the only option. Okay? So, now, let's look at deterministic algorithm. The deterministic algorithm is typically the one that is implemented in any operating system when you choose how long does it wait before it shut down the hard drive. Okay, usually you have a scale, you choose 5 minutes, and then after 5 minutes it shuts down the hard drive. Okay? So, what is the deterministic algorithm? So what is the deterministic algorithm for this problem? Yep?
You let the hard drive on until you pay Y, then you shut it down
This is one. But what are all the possibilities for deterministic algorithm? Yeah. So let's wait. So this is the algorithm AW. Okay. Wait time W. Okay. Wait. Wait. No. So it's if the request did not arrive before time W, shut down the hard drive at time W. Okay? And then restart the hard drive when the request arrives. Okay? Good. So these are the deterministic algorithms. 2. What is the optimum algorithm? I mean, what is the optimal cost? Because it's not an algorithm. What is the optimal cost? So given that we know when the request arrives, what is the optimum cost? Imagine that the request arrives at time t. Arrives at time t. Exactly. Okay. Either you let the hard drive run until the request arrives, or you just shut it down immediately and restart it when the request arrives. Okay. There is no reason why to shut it down in between in an optimal strategy. Either because else you would have paid for nothing. Okay. So the optimum cost of the instance where the request arrives at time t is simply equal to the mean of xt and y. Okay? So let's now compare the cost, the optimum cost to the cost of algorithm AW. So there are two cases. So this is t and this is the cost. Okay? So there are two cases. Either W is less than Y over X. Okay, W is a time, so it should be homogeneous to a time. Okay? Y is in euros, X is euros per time, so it's homogeneous to time. It's okay. So why is it important? Because this minimum here, these two lines here, cut exactly at t equals y over x. Okay, so what's the optimum? The optimum is simply that, where here it's t equals y over x, and this is equal to y. Okay, that's the optimum. This is the optimum. Okay, so let's now look at what AW does. When W is less than that, this means that I will pay X until I shut down the hard drive. Okay, and I shut down at time W. And then, for serving the other ones, I will pay Y more. This is the cost of AW over for request IT. Okay, this is clear for everyone? So, your cost increases with t at a rate x until you shut it down, and then you will pay a fixed cost, which is that plus the cost to restart the hard drive. Okay, so this is your cost, depending on the request arriving time of a request. And I can do the same drawing for y larger than